Yeah, so welcome. Today is June the 15th. We thank God for keeping us to the middle of this month. I welcome you all to class, and we are going to have some interesting time. Today, I'm reaching you from Paris. I'm still here. I'll be returning tomorrow to Nigeria. I'm sure you all are fine and with your families. So today is going to be a multivariate analysis of variance and multivariate analysis of covariance. And we have three eminent doctors to present to us. Dr. Faith Omoraka, followed by, I can't even see him online. Felix is not online. And of course, we have Madam Mary there. Let's see. Yeah, so let us have load the presentation of Madam Omoraka Faith. I'm loading mine now. I have it all set, and let's now invite him to take the floor. Madam,
Okay, sir.
yeah, please carry on, Dr. Moraka Faith.
Good evening, sir.
Yeah, good evening.
Good evening, my fellow doctor in the group.
Good evening,
We'll
Good
be
evening,
looking at multivariate analysis of variance, and we'll also be looking at MANCOVA. Now, for MANOVA, I want us to go to slide 2 of my presentation.
Yes,
and
we're there.
I want to look at what MANCOVA is. At MANOVA first. MANOVA is a statistical test procedure for comparing multivariate means of several groups having two or more dependent variables. It is a technique for assessing group differences across multiple dependent variables. Before we continue, I want us to go to slide 3, which has major keywords that we'll be discussing as far as this presentation is concerned. We're looking at dependent variable. We want to know what a dependent variable is. Now, dependent variable is that variable that depends on the other variables in the study. It represents the output or effect. You can also call it response variable. You can call it exchange variable. You can also call it output variable. Still on slide 3, we also have the independent variable. The independent variable represents the inputs or causes. They are the cause of the effect on the dependent variables. Look at its value in the study. We can also call it the control or the manipulated or the predictor variable. Now let's look at multivariate. Multivariate means many. That is many variables. However, reference is to the number of variables. If one dependent variable, if we have to go to slide 4, slide 4 shows advantages of MANOVA. Now, MANOVA increases your chances of finding a group difference. MANOVA is sensitive not only to mean differences, but also to the direction and size of correlations among the dependents. Since only one dependent variable is tested, the researcher is protected against inflating the type 1 error due to multiple comparisons. On slide 5, we want to see how, when we use MANOVA. We use MANOVA when there are more than one dependent variables, as well as independent variables within the model which the researcher wishes to test. When we want a valid alternative to the repeated measures ANOVA, and when sperativity is violated. We also use MANOVA when multiple univariate analysis presents a picture that is not comprehensive or decompositive on the interrelationship. I want us to look at a research question to be able to understand what independent variable is in MANOVA. The research question we have on slide 6 shows the effect of photographic image on the achievements, attitude of science, and practical skills of basic 5 pupils in Apapa local government area of Lagos State. You see some words.
Is it attitude of science? Sorry, Madam Faith. Is it attitude of science or attitude to science?
Attitude to science, sorry, sir.
Go ahead. No problem. Go ahead.
Okay. for using MANOVA. That's on slide 7. Assumptions for using MANOVA. The assumption of MANOVA is the NHR, which is normality, random assignment, and homogeneity of variance. But there are more detailed assumptions, which is multivariate normality. The something of the dependent variables and all linear combinations of them are normal. Then homogeneity of variance, covariance matrices exist. Then under linearity, it is assumed that linear relationship between all pairs of dependent variables exist. Then we have the multicollinearity and the singularity. Multicollinearity shows the relationship between pairs of variables, which means that they are I. Therefore, R is greater than A. While the singularity is when a variable is redundant. That is, there is a combination of two or more of the other variables. Let's go to slide 8 quickly.
Yes, we're there.
Yes. MANOVA.
Okay.
Should I continue, sir?
Yeah, please go on. We're enjoying your class, your presentation. Okay.
Yeah. Data to apply. We need to understand that when using MANOVA, the data need to conform to the parametric assumptions. And remember not to put too much highly correlated dependent variables. Also make sure that you check your compliance with boxes M and 11 set. On slide 9, we want to see how much data do we need when computing MANOVA. Make sure that you have more participants than dependent variables. That is, you must have at least more than 2 participants. Then your sample size should be at least 30. And if you are using the cell size of 30 for 80% power, make sure that it's not lower than 7 per cell. We want to look at the mathematical model for MANOVA.
What slide is that?
That is slide 11.
Okay, so you are jumping slide 10.
Sorry, we skip an important slide, which is slide 10.
Yes.
We want to see what does MANOVA do. MANOVA examines the degree of variance within independent variables and determines whether it is smaller than the degree of variance between the independent variables. It also looks at variables within and variables between. This helps us to see whether there is a difference in chance or real life. Okay, presently we are on slide 11, which shows the mathematical model for MANOVA.
Yep.
Now, the model begins when MANOVA creates a new jumbo dependent variable that attempts to maximize the differences between the treatment groups. The equation we see there shows the linear conditions of the dependent variable, shows that the linear condition of the dependent variable is achieved. On slide 12 and 13, we have the MANOVA statistics. Slide 13 is showing us the 4 statistics that are used to run MANOVA, which is the Weeks-Lambda,
hold on, what did you call it?
Weeks-Lambda.
Lambda. There's
Weeks-Lambda.
Yeah.
Then we have the Hotelling trace, Phileas trace, and the Roy's largest root. I'm going to just
maximum root, please.
Roy's maximum root. Thank you, sir. The Weeks-Lambda.
Lambda. Pronounce it 3 times. Pronounce it 3 times.
Okay, let me explain the Phileas trace.
No. Pronounce Weeks-Lambda 3 times.
Weeks-Lambda.
Very good. Go on.
Okay. Phileas trace totals the changing value for the BT1 matrix.
Sorry, pronounce it. Hello. 1 minute. Pronounce it eigenvalue.
Okay.
Eigenvalue. Now, all of you, please pronounce it eigenvalue. All of you. Eigenvalue. Very good. So go on, Madam Faith. Go on. Yeah.
So the Phileas trace totals the eigenvalue for the BT matrix, essentially the sum of the variance accounted in the variance. Um, when reporting MANOVA, we
Which slide are
use
you? Which slide are you, madam?
I'm on slide 14.
Okay.
For us to run MANOVA, we need to use statistical packages for the social sciences, which is SPSS. And if you need to do that, you launch SPSS, which you must have already installed on your system.
Good.
You import your data, you go to analyze, you go to multivariate, you reset. But for us to get a proper understanding of everything about MANOVA, I want us to watch the video on Peter Okebukola MANOVA on YouTube. That will give you a better understanding of all what I've been saying and a practical usage or method of using MANOVA. Go to slide 15. When
Yes.
reporting MANOVA, we should be very careful to make sure that we report especially the 5 most important tables, which is 1, descriptive statistics table. The descriptive statistics table provides mean and standard deviation for the 2 different dependent variables, which have been split by the independent variables. It provides total rows, which allows means and standard deviations for groups only split by the dependent variable to be known. Another important table is the multivariate test table. The multivariate test table is where we find the actual results of the one-way MANOVA. You need to look at the row operations lambda to determine whether the MANOVA was.
Can you pronounce that word determine rather than determine? Can you say determine?
Determine.
Very good, madam. Go ahead.
Thank you, sir.
Yeah, thank you.
Then we also need to look at test of between subject effects. It helps to determine the dependent variables differ for the independent variables. Then another important table we need to look at is the box test of equality of covariance. It shows the significant level. And the last important table, which you need to look at when reporting your results in MANOVA, you need to look at the Leven's test of equality of error variance.
Can you pronounce it Levin, not Leven?
Levin test
Good,
of
madam.
equality of error variance. Thank
Very
you,
good.
sir.
My pleasure.
It shows significant level. Test the null hypothesis that the error variance of the dependent variable is equal across each group.
Wonderful.
Thank you very much. That's all for MANOVA.
Yep.
Let's go to slide 17, which is MANCOVA.
Yeah.
MANCOVA is multivariate analysis of covariance. MANCOVA is the multivariate of ANCOVA. It tells you if there are statistically significant mean differences among groups. In other words, it tells you if group differences probably happen by random chance or if there is a repeatable trend. You can see what MANCOVA really looks at from that small image we have there. Then let's look at types of MANCOVA, which is slide 18. From my research, I was able to find out that we have 2 types of MANCOVA. One-way MANCOVA. One-way MANCOVA needs at least 4 variables, 1 independent variable plus 1 or more dependent variables, and 1 or more covariates. Then the two-way MANCOVA includes 2 independent variables. Slide 19 will be telling us what MANCOVA does. Now, MANCOVA compares 2 or more continuous response variables. It removes the effect of 2 or more covariates from your model, and is also used to account for what is called increased experiment-wise error rates. MANCOVA also tests multiple hypotheses concurrently and adjusting several outcome values at the same time with a covariate.
You have 2 more minutes, madam. 2 more minutes.
Okay. When do we use MANCOVA? We use MANCOVA when there is no randomization. That is when there is an intact class, when we have more than 1 dependent variable, and when we have more than 2 groups. On slide 21, we see an example of MANCOVA. You see the independent variables and you see the dependent variables. Assumptions for using MANCOVA, slide 22. 1 is normality. Each dependent variable must represent a normal distribution of scores. Violation of this may lead to type 1 error rate. Then independence of observation. This means that each observation must be met by other observations. This assumption can be met by employing random sampling technique. Then we have the homogeneity of variance, which says that each dependent variable must demonstrate similar levels of variance across each independent variables. Then homogeneity of variance, which is the main reason why it is called MANCOVA. The intercorrelation matrix between the dependent variable must be equal across all levels of independent variables. Slide 23 gives us a summary of MANOVA and MANCOVA. You can see what I did there. In MANOVA, there is randomization, two or more dependent variables, and does not violate any assumptions. I'm sorry for there's an error there.
No
Then
problem.
MANCOVA, we use insert class, two or more dependent variables, and violate assumption of randomization. That's why we use the insert class. In conclusion, if the statistical assumption of a MANCOVA can be met, it is a much more powerful inferential statistics that can yield both main and interactional effects while controlling for a covariate. On slide 25, we have my references, and thank you all for listening. That's all.
Thank you. I didn't hear the applause for her. Madam Moraka Faith, you win. I'm going to give you a special present from Paris when I come because this is wonderful. Yeah, this is wonderful. You please recall that we only gave her this topic yesterday night, about almost midnight, and she's been able to come up with this very, very wonderful presentation. So let's now take discussions, something to add or some questions to ask. So let's go, Helen.
Sir, and that is a wonderful presentation, Madam Faith.
Thank you.
Highly delighted. And your slide, I think the front, you can make it bigger than this. And also, I want to ask, in your presentation, what is the covariate there?
Okay, just make a note of that, Madam Faith. Samuel. Stephen.
A very good presentation, Madam Faith. I must appreciate your slides. They are not too loaded, and
Yes.
you've been able to speak to the slides.
Exactly.
Not that you are reading. I
Yeah.
give you an applause for that. God bless you.
Thank you, sir.
Yeah, no, don't go. I've said I'm not going to take just the applause for that. You got to ask a question. I'm going to come back to you if you don't have a question just yet. I'm going to come back to you. You got to
Okay,
ask a
sir.
question. Madam Mary.
Yes, sir.
Olayanju.
Yes, I need to really appreciate our work because considering the time lag, for doing something substantial, just an appreciation of our work.
Yes. What's your question? I'm going to come back to you. I've said it. There's some ground rules for this class. You are doctoral students. So it's not a question of appreciate your work. You just must have to ask a question. Larry. I'm coming back to you, Mary. Yeah. Larry.
Yes, my question.
Good.
Madam
Just go
Faith,
straight.
first of
Your
all,
question.
appreciate your
Yeah.
work.
Now, by the
Yes, my
way,
question
no,
is,
hold on, Larry.
was like
Hold on, Larry. By the way, the flow of events will be like this. I'm going to appreciate the presenter on behalf of all of you. So there's no point in everybody now saying you have done well. Just assume that you have done well based on my summary of what I'm hearing across the table here. So just go ahead and ask your question, just like Larry is doing. Larry, go
my
ahead.
question is on slide 11,
Yes,
the mathematical model.
sure.
I always have an issue with all these mathematical formulas without being explained properly. What A means, what W means, what P means. So if you can help us explain more on those things so we can understand
Okay.
what it means, I will appreciate it so much.
Okay. Now you recall that in class, when I give you that model, I don't want ever for you to get intimidated by those models. Look, I've gone through advanced statistics classes in my postgraduate days, and all these people try to scare you with all of these big, if you like, grammar in mathematics. So just Mary, in answering it, you just go ahead and summarize the thing, but don't get intimidated. That's what drives people away from statistics. So, Larry, when you're presenting your own, don't spend more than a few seconds on the mathematical model. That's what the model
Exactly.
looks like.
Yes,
Don't
sir.
just waste my time on that. Peter.
Yes, sir. Yes, sir.
Peter is not ready. Billy. Yes. Your question. Okay, if you're not ready yet, I'm coming back to Stephen. What's your question?
On slide 19, what does MANCOVA do? The first thing you wrote there, you said compare two or more continuous response variables. And if you look at it, MANCOVA also do something similar. So I just want you to explain better what you were trying to say when you say compare two or more continuous response variables.
All right, thank you. Mary, back to you.
Yeah, on slide 9, the third point there, we have cell size of 30 for 80% power.
Yes.
No lower than 7 per cell. So I would like us to throw more light on the third point, sir.
Okay, that's very good. So back to you, Madam Faith Omoraka. Now, have I pronounced your last name correctly? Can you pronounce it for us?
Yes, sir. Omaraka, sir.
Very good. Where are you from, by the way? Which state?
I'm from Delta State, Amurobo, sir.
Okay, Miguel. I schooled in Saple, and
Okay, sir.
when were you born? What's your birth year? Sorry, you don't ask a woman about her age, but what's your birth year? When were you born? When is your birth year?
83 June, sir.
You were born in 1983?
Yes, sir.
Oh, that's good. That's good. I was in the secondary school 1963 in Saple. So that's a good I carry memories of my stay in St. Malachi's College in Saple. Thank you. So give a response to all of this.
Okay. Madam Mary talk about slide 19, right? Madam Mary.
Yeah, go ahead.
Slide 9.
Slide 9.
Talk about slide 9.
The fourth point on slide 9.
Okay. That is, this 30 means that your participants, when you are using your cell size, sometimes we have group and we have different cells. Your cell size must not be more than 7 per cell. Do you get that?
Mary, just say you get it.
And
Yeah.
Dr. Larry, you complain about the formula. Prof already said that we should not be intimidated by the formula. Even me, I've never loved mathematics because of those big formulas that I see. And moreover, now we have a better way of computing statistics. We
Yes.
can run our statistics on SPSS.
Yeah.
So please, we should not be intimidated by the formulas that we say.
Okay.
Thank you very much.
Thank you very much. Yeah, I think we need to applaud her again. She has done very well. Okay. So, Samuel, are you set?
Thank you very much.
Samuel, are you set? Yeah, it's okay. Samuel, are you set? Okay, that's fine. So let's see the second presentation. Also, MANOVA. This session will be presentations on MANOVA and MANCOVA. Lekon started yesterday, but we had to abort. So we're going to take his presentation now. Okay, Samuel, if you are ready, we are ready. Let's load your slides. Please go ahead. Go ahead, Samuel.
Good evening, colleagues. My name is Edward Oladipo Samuel, and I will be presenting on MANOVA and MANCOVA. On slide 1, I have my...
Is this slide 1? Slide 1 is the title slide.
Yes, and I'm going straight to slide 2, which is the introduction of multivariate analysis linears, MANOVA. MANOVA, the main difference between MANOVA and ANOVA. Thank you, sir. The obvious difference between ANOVA and multivariate analysis of variance is the M, which stands for theory. And to put it then, a MANOVA applications are independent one another. There is no pattern of selection. We have to give everybody, every subject, an equal chance to participate in the research work.
Sorry. If I were you, somebody just finished presenting, you are wasting
Yes.
precious time. All you need to do is assumptions that independent random sampling, level and measurement, and move on. Please go ahead.
And briefly to slide 7, sir. I'm looking at MANOVA, and we have level test, box M test, and it continues to slide 8, where we have the partial income stock test and multivariate S test, the statistics. And the slide 9 have models of MANOVA. However, also I have this phobia for mathematics. So I believe and I always thank the initiators of SPSS. So to slide 10, we want to look at when to use MANOVA. And the basic requirement for using MANOVA is what we have in slide 10. When we have 2 or more continuous dependent variables and 1 or more categorical independent variables. And in my slide 11 of my presentation, I have a window, a picture of the Windows SPSS window. When you want to analyze MANOVA with the SPSS, you go to analyze, then the general linear model, and you click on multivariate, and voila, you get your MANOVA statistics done. And so I'm moving also to MANCOVA now in my slide 12.
Yes, go ahead.
MANCOVA, also like MANCOVA, is just the difference between MANCOVA and MANOVA is that there is C in MANCOVA, and C stands for variance. Both MANOVA and MANCOVA feature 2 or more response variables, but the key difference between the two is the nature of independent variables. While MANOVA can only factor, an analysis involves from MANCOVA to MANCOVA when 1 or more covariates are added quickly. And like Prof always told us in education, if we have MANCOVA, we use our covariate. We use MANCOVA when we have interclass, and we use the pretest as the covariate.
That's correct. Go ahead. I said that's correct. Go ahead, yeah.
And quickly to slide 14, I have the assumptions for MANCOVA. And the assumptions for MANCOVA is the same thing as the assumptions for MANOVA. But there is one major assumption that is different, which I have in slide 15, and it is the relationship between covariate and dependent variables. And also, on that note, I will be ending the presentation. Thank you, and God bless.
Wonderful. Thank you. I didn't hear the applause for Samuel. Samuel, don't worry. You see, one major advantage of that of Samuel is that he showed us the SPSS procedure for doing the analysis. I like the quotes now trick that Madam Faith used. He said, if you are interested in knowing about all those steps, go and watch the other YouTube, which is fine, which is quite good. So you see, together we're getting a good picture of the multivariate analysis of variance and multivariate analysis of covariance. So we're going to start with the questions. Mind you, I've congratulated Samuel, so we don't need again to be saying he has done very well and all of that, because we have all approved of that by way of our applause. So, Gbedeyi, any question? No. What's your question? Not any question. What's your question?
Thank you, sir. My question is that is there any pattern for selection of a sample in MANOVA?
Okay. So please know that, Samuel, Faculty is just joining us, so he may not have caught up with it. Larry.
Yes, sir. My question is on slide 8.
Yes.
I'm more concerned about asking the partial eta square.
Yes.
Shows how much variance is explained by the independent variable. I want someone to just show more light on that, sir.
Okay, that's fine. You know what gladdens my heart, Larry?
Yes, sir.
Yeah, you are the class captain more or less, and
Yes, sir.
we have been missing you in class. So I'm glad that your audio, everything is working perfectly now. I'm quite happy about
Very
that.
much, sir.
Yeah,
Thank
yeah,
you
okay.
very much.
Mary, over to you.
Yes, sir. I would just like him to go to slide 12 and then just shed more light on when we have it is simply a maneuver where the artificial DPS are initially adjusted for different in one or more periods.
Wonderful. Thank you. Madam Faith?
My question is still on slide 12.
Yes.
There's something like error noise. I don't really get what error noise is in this presentation.
Okay, Madam Faith, your audio comes out, the best in the class
Thank
today.
you, sir.
Very very clear, very sharp. Yeah, Stephen, Shino.
Good evening, sir.
Yeah.
I'm on slide 7.
Yes. Also very clear. Yeah.
You talked about MANOVA key concepts and terms. The Levene's test of equality of variance, the box M test we watched in Professor Okebukola's MANOVA YouTube video. I wanted to share light because you didn't really talk about it, maybe because of your time.
Yeah, that's good. Good question. I was to ask that also. Helen.
Sir, I want to ask him about the Levin's test. If it is not significant,
Yeah.
what are we going to do about it?
Exactly. That's the same question that Stephen asked, and that's the same question I'm going to ask. If you have the box M test and the Levin's test being not significant, is that good or it is bad for your model? So back to you now, Samuel.
Okay, sir. Dr. Pule, selection pattern for MANOVA. Selection pattern for MANOVA has to be random. We have to select the sample is randomly selected. And that is for Dr. Pule. The error noise, MANCOVA. What the error noise is, what the error noise means is that, okay, let's say in MANOVA, when we run the test for MANOVA, we have a true error. And when we are doing it continuously, it becomes like what Dr. Kennedy asked in class, running a multiple ANOVA on a data. Or in when we put together in MANOVA, make the error very minimal. For instance, let's say we are looking
Okay, you need to round up quickly because there's some noise from your end and it's not not making the background noise is not too helpful. So just round up quickly. Take on the Levin's test box M text result.
when the box M test is not significant,
That means what?
that we can go ahead.
Exactly. That means the model is good. Are you happy with that, Helen?
Yes, sir.
Are you happy with that, Stephen?
Yes, sir.
Wonderful. That's it. Now let's applaud him again for a job very well done. So, still moving on with MANOVA and MANCOVA, we'll take the last presentation for today, and that's by Dr. Mary Olanyonju. Are you set, madam?
Yes, sir.
Oh, okay, fine. So let us try to get our presentation. What's the time stamp on that one? Yes, madam. Yeah. So ours is 426. So let's load it and get it working. Do I have it? Yeah. So go on, madam.
Good evening, sir. Good evening, my amiable colleagues. This evening, I'll be presenting on
multivariate analysis of variance, MANOVA, and multivariate analysis of covariate, MANCOVA. Now, before I go on with my presentation, I would like to really appreciate the Prof, our professor, because throughout this time I've always had a phobia for statistics, but there's a way it took us through so many opportunities that have really allayed my fears.
Thank
So
you,
having
madam.
said that, I'd like to continue with my presentation.
Thank you, madam.
Now, yes, sir. So, when we talk about MANOVA, what are we talking about? MANOVA stands for the newly created combination that different from by different groups. And in this way, MANOVA essentially says whether or not the independent grouping variable simultaneously explains a statistical significant amount of variance. The obvious difference between, when you talk about MANOVA,
Can you be telling us the slide that you are on? Madam, just be telling us the slide that you're on because you're not telling us anything.
I'm still explaining that slide, sir.
Pardon?
I am still explaining the fourth slide, sir.
No, slide number what?
Four.
You didn't tell us four. Go ahead, though. Go ahead.
Sorry, sir.
Okay.
Can I continue, sir?
Please go ahead, Madam Mary.
Yes. Having the background of MANOVA. So MANOVA is an ANOVA with two or more continuous response variables. And it has a response flavor and a two flavor. What distinguishes the one flavored side, that's the one-way MANOVA and the two-way MANOVA is the factor variable involved in it. Now let's move on to the next slide. Slide 5.
Okay.
Now on slide 5, I have tried to, tell us what multivariate.
I think I may have to take off Fakunle again because there's some noise coming from his end. I've done so. Please go ahead. Yeah.
Yes. Because if one does not really understand what that prefix multivariate, what it means, that word, you may be confusing it. So when you talk about multivariate, you are talking about multiple or many variables. But this multivariate is with respect to independent variables. So when you talk about multivariate analysis of variance or multivariate analysis of covariate, we are talking about two statistics that involve more than one dependent variable. Now, there are some assumptions that are guiding the use of MANOVA.
Can you please, madam, you know what the others will say? Next slide, slide 5. You are not doing that. So
slide
please.
5.
Please.
Slide 6, sir.
Okay.
Yes, sir.
Go ahead.
Okay, sir. When we talk about the assumptions guiding the use of MANOVA, we have them on the slide. That there should be normality of population, there should be homogeneity of variance. And MANOVA, one must always know that in MANOVA, before you can consider the use of MANOVA, then that means you must have the opportunity to randomize your subjects into different groups. So there should be opportunity of assigning subjects into different groups. And of course, there shouldn't be multilinearity between dependent variables. They shouldn't have strong, multilinearity between themselves. And the next assumption is that the independent variable should be categorical. Now, by categorical, for example, sex, that's gender. Categorical is just divided simply into categories, either male or female, or you have the school type where you have the private or the public. So those are examples of categorical. And when you say the dependent variable should be continuous, of course, this can either be ratio or scale. And examples of this include test scores of students, either the achievement test scores, post-achievement test scores, or pre-attitude test scores, and the like. So those are examples of continuous variables.
Okay, ma'am, you are spending too much time. You are spending too much time on the assumptions. You need to go very quickly. You have just about
another
6
example
minutes.
is that's on slide 7, where we have a topic, research topic, effects of digital games on the achievement and attitude, balancing the equation among basic science aids in Lagos State. Trying to say that the achievement and attitude there are the TVs, they are the independent variables, and they are
Correct.
continuous. While the independent variables there, the use of digital games to teach the students.
Good.
Now, on slide 8, we, how do we compute MANOVA using SPSS?
Very nice.
I have tried to tell us some of those steps that are involved. After you upload your data, you go on to analyze.
Good.
The dialog box that pops up that tells us so many things, and on that analyze, click on general linear model.
Yep.
Then since you're talking about multivariate, it is not ANOVA, neither is it MANCOVA. So we are talking about MANOVA, so that means we are talking about, you click on multivariate. Then the next one is you transfer the dependent variable to dependent variable box. So like the example I gave on slide 9, on slide 7, the post-test course here will be used. The post-test course of the achievement test and that of attitude. Then you go on to your ID, that's the invented variable. So on and on, there are some steps that I have highlighted, which also continue. Like I said, let's go to slide 9.
Yes.
But MANOVA is a bit, it's more complex, it takes more steps than ANOVA. So let's just use some other slides, some other steps. So you click on model, the full factorial, you click on options, select the independent variables into the display means. An example of that on slide 11. Let's go to slide 11.
Good.
So on slide 11, we can see the data there. We can see the data. We are on the variable view. Then in the variable view, we can see analyze on top. Then you can also see compare linear model. The next one is multivariate.
Yes.
Then let's go to slide 12.
Very good.
Now, slide 12 tells us how to transfer the dependent variable to the dependent variable box. And see as highlighted, as shown rather by the arrow.
Very good.
The first arrow on top. And this arrow below tells us of the fixed factor. Now, I need to put this straight. When you talk about the fixed factor, we are referring to the independent variable.
Correct.
And if you talk about the dependent variables, they are just, your test scores, your post-test scores. So let's go to slide 13. A way to always help us not to confuse these two statistics is to be able to tell us the similarities, and you should be able to tell also the differences. Now, one major similarity between MANOVA and MANCOVA is the M that starts both of them, that's the multivariate. So when you talk about MANOVA and MANCOVA, we're talking about statistics that make use of more than one dependent variable. Okay, so let's go to slide 14. Slide 14 compares between, the differences should have been up.
No problem.
That's the title of that slide.
No problem.
Between MANOVA and MANCOVA. Now, there are two of them. The first one is in MANOVA. Before you think of MANOVA, you have to think of have you randomized? Is there opportunity for you to, put your sample to randomize, randomly select your subject or your participant into group? That's MANOVA.
Yep.
But if not, when you use inter-classes, like in quasi-experimental research work, you're talking about MANCOVA. Okay? Then the next difference is that no covariates are involved in MANOVA. When in MANCOVA, covariates are involved. Let's go to slide 15.
Good.
MANCOVA is useful in educational studies where randomization is not possible. Then slide 16 tells us of what MANCOVA means. It is statistical technique that helps us, it's an extension of analysis of covariance. And so when you talk about when you're having covariates in your mind and you're also having multivariates in your mind, statistics use MANCOVA.
Sure.
So the assumptions
Yeah,
guiding the use
please
of
round up in about 1.5 minutes.
MANOVA are almost the same, except for that in MANCOVA, you know, you have opportunity. Sorry, the first point shouldn't have been random sampling.
That's
Because
correct.
I'm sorry,
This not
sorry,
on. Yeah,
that's
correct.
yeah.
Correct. Yeah.
Yeah. There shouldn't have been random sampling in MANCOVA. So my conclusion is both MANOVA and MANCOVA use more than one dependent variable. Then the choice of what to use depends on the concentration of a covariate and if randomization of subjects. Thank you for your audience. I'm very grateful.
Wonderful. Mary, you can hear the applause. You've done very, very well. First, let me deeply appreciate you for your kind words at the start of this your presentation. I also appreciate you. You are dutiful, although you come late to class occasionally, but you quickly meet up. You catch up. Well done, madam. I know you live very far. From campus, but you still make the efforts, and I can see very clearly that you understand the 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 essence of all of these statistical tools, especially MANOVA and MANCOVA. I also like that you presented the SPSS, a few of the SPSS snapshots of screenshots of the analysis. So very well done. Now we're going to take questions. I'm going to go from my panel here from my right to the left, and I'm starting with Helen. Helen, go ahead. Yes, go ahead. Yes.
Yes, sir. Madam Mary, I want to ask you, the MANOVA. You are saying that there's no, that means there's no covariates are involved. While in MANCOVA,
yes,
no covariates are involved.
That's correct.
Right?
Yes.
And in MANCOVA, covariates are involved. Now, I want to ask that. My question is this: what if you have it in mind that you want to use MANCOVA, and when you get to a school, you will now ask that, for example, in the school we have interclass when you want to use MANCOVA, and when you get there, maybe they are on break, and the students are all over. What can you do? What do you think you can do to solve the issue?
Okay, thank you. That's a practical question. No, just make a note of that. Yes, Samuel, your question.
Thank you, sir. Just want to ask whether MANOVA.
I can't hear you, sir.
I also cannot hear him. The sound from Samuel is not so exciting. But just do your best, Samuel. Just ask a question, be straight on. Yeah.
I want to ask MANOVA can be practical, like previous situation.
Okay, I cannot hear him. So don't worry, Mary. When we're in class, you can ask your question. You can ask the same question and then you provide an answer. Stephen.
Madam Mary,
Yes, sir.
my first question is on slide 6, where you mentioned, we've seen the NHR, the assumptions, but you said absence of multicollinearity. And the explanation wasn't too clear. And we know from Prof that multicollinearity is just talking about when you have two variables that are highly correlated.
Correct.
Correct.
Yes. Go ahead.
So I want to suggest absence of multicollinearity so that it doesn't confuse. We could just leave it as multicollinearity. They just explain that it is a situation where you have two variables that are highly correlated. That means you can easily predict. So probably the absence there should go up. Then on slide 15, I think you've been able to clear that, talking about randomization, where to be used at MANCOVA or MANOVA. Then you were interchanging covariance and covariate. When you want to do a multiple analysis of covariance, you have it as multiple analysis of covariate. They they were interchangeably used. Thank you.
Okay, thank you very much. Noted. Let's see who is next. Madam Faith.
Thank you, Dr. Mary. Actually, I wanted to ask about what Dr. Shina just mentioned about the multicollinearity. And I'm
Okay.
cleared on that now, sir.
Very well, thank you. Larry.
Yes, my question is on
Dr.
slide
Larry
6 as well.
Ariyibi. Dr. Larry
Yes, sir.
Ariyibi. Yeah, that's it. Your
Yes,
question is
sir.
on,
Thank you
on
very
what? Slide
much,
what?
sir. Slide 6.
Slide 6. Yeah, so let's
Yes.
go get it. Go ahead.
The sixth bullet there says that there should be more participants than the dependent variables. I think that is not clear, sir, because participants in dependent variables is not a clear explanation, sir. So I want her
Okay.
to shed more light on that.
Okay, she will, I'm sure. Who is next? Gwede, you are there? Are you there? Yes, your question? That'll be the last for this for today.
Can you speak louder?
We can't hear you, Gwede. It's as if you are in where now? You are in Agege. It's very, very far. Can you speak louder? Yeah, better now, so you can speak louder like this. So go ahead and ask.
I just have to explain your fixed factor from your topic when you want to use SPSS.
Pardon?
Yeah, we can't see hear him. No, he will ask that question in class. The thing is fit. So please, Madam Mary, respond to the ones you can hear. When we get to class, they will be asking you the questions. Yeah.
Yes, starting with Dr. Ellie. In my opinion, I feel you have to change that. The two. You feel when you get to the right set of people are not on ground and you want to get the best of your work, I feel you should change the statistics. That's one. Then two for Dr.
Sorry, can you repeat that answer?
Yes, she asked the question that corresponds.
No, we had the question. I'm asking you to repeat the answer. What answer are you giving?
Yes, my opinion of the question is that she may need to change the statistics because if from what she has said, the inter-class most of the students have gone on holiday and you need to use some other where randomization is possible, then that means you won't talk about MANCOVA.
Yeah. Okay.
Then the next one for Dr. Shino. Dr. Shino gave me some I think they are point notes and they are well taken.
Okay, that's fine.
The last question, I didn't really get the last question very well, sir.
Okay, you get the question in class. I think we've had a very nice day. The seminar has been quite exciting. We had 3 presentations from 2 scholars, starting with Madam Omoraka Faith, and then Samuel, and then Madam Mary. We now to bring this to a close and to thank you all for a very, very wonderful session. Recall that we're meeting in class on Saturday. I asked that you should fill some online forms for discriminant analysis to get data. Have you been able to do that?
Yes, sir.
Okay, fine. Just get some. Then we're going to do discriminant analysis because I think that Madam Faith, you are also doing discriminant analysis. Are you doing that?
Yes.
Okay.
Yes,
So
sir.
it will yeah. So it will give you a feel of how a practical feel of how discriminant analysis is done. So, can I bring the class to a close now by thanking you all and wishing you a very, very fine evening. As I said, merci beaucoup. I had to move. Did you see some of the pictures I sent yesterday?
Yes, I
Oh yeah, we are having the closing session. Thank you. We're having the closing session this evening. That's why I had to move the class back. It's actually starting at 7 o'clock at time. I'm 15 minutes late, so I got to rush for the closing session. I'll be on my way back to Lagos via London tomorrow. I'm sure you wish me a safe trip. Oh yeah, bon voyage. Okay, thank you. Okay, class. Bye bye now. See you. Bye bye. Thank you. God bless you. Thank you.